Hello and welcome guys to the second part of Databricks AI Security Framework video series. So in first part we covered a lot of interesting insights. We covered a bit about what is generative AI. We covered the main risks, the main security incidents that happened previously, and just discussed why AI security becomes very important. And now this series, we're going to build on that information and essentially dive a bit deeper into, we're going to cover machine learning life cycles. We're going to cover machine learning personas. We're going to look and discuss the actual risk framework and the model of 55 risks. We're going to talk about a bit what's the whole life cycle and what is made up our AI model sort of building life cycle and all of that. So stay with us guys, and we're going to cover some really interesting and informative ways how we're going to secure our AI models. Hopefully you guys learned a lot from the first video, and then we're going to dive in deeper and then cover the some of the interesting material in this video as well. So let's have a look at our machine learning model lifecycle. So I think it always starts with we getting raw data in our ML lifecycle. We need to prep that data, then we do training and evaluation, and then essentially deployment. And then that cycle keeps continuing happening, because what we do is we get a feedback from our deployment, and then we add again raw data, we do again data prep, training and evaluation, and then deployment. So that cycle never ends. So it's important to understand that in that cycle, it's important to make sure that we cover integrity. We put specific security controls to prevent that model lifecycle from ever changing and from being exploited. So we're going to cover how we're going to address some of these risks and the importance of making sure that we have the right security controls in place and making sure we address those security risks with prompt controls. So let's dig in deep and look a bit deeper. So I think the most important part to understand is, whenever we start talking about, ML or machine learning, is that, the hardest part of ML isn't the actual ML itself. As you can see in this graph, and it kind of very neatly displayed where the machine learning itself sits within, the rest of the work that's being done. It's only a small part of it, but we need to make sure that we have the right configuration. We have the way how we do data collection, make sure there is no bias in our data. How do we do data verification? How we do machine resource management analysis tools? We have feature extractions. We have process management tools. We have the serving infrastructure, and then we have to have correct monitoring in order for us to be able to detect any deviations while measuring things like loss in our models. Bias, making sure we do ethical considerations and things like that. And obviously, there's a lot of infrastructure involved that where things can go wrong. So I think it's a very good graph just to cover and understand that, ML or AI, it's not end at all. Obviously we still need to have the sound cybersecurity controls and, So sound security is not can't be forgotten. There's no specific controls just that's going to protect a part of the ML. We have to do that holistically. That's why we always say defense in depth, because you have to cover all of the processing part or all of the steps in our ML model build out to make sure that we protect our models. So if we go ahead, I just want to cover and build essentially sort of a picture so you guys understand. Those of you who haven't, maybe dove deeper into AI system components, we're going to build a whole picture and how this model is going to build from data operations to model operations to actually DevSecOps. Let me take in a swig of coffee and carry on. So we're going to start with, obviously, all starts with data operations. So first of all, we start with raw data. Then we're going to add data preparation, or ETL. Essentially, there's pipelines where we clean data, where we potentially do data analysis, we potentially maybe doing even featurization, potentially transformation of that data. Then we move on to Data sets. Now, this is the important part. Those of us who, if you haven't intimately worked with AI models, it's whenever we're using data, we don't use 100% data to train the model. We always split the data into sort of features or separations. As I said, we have a training data set and we have a test data set. So what we're doing is normally, say we're doing 75% and 25% split. So whenever you split the training data, that's where we train the data. Train the model on that training set data. But once we train the model, we need to verify that the model has been trained, and that's how we train the accuracy based on the test set data. Because essentially what it is, it's the same data. So whenever you're training on 75% of the data, you can then measure the output, that how close it is to the test data, which is the last 25% of the data. Then once you obviously done this, then you build essentially a catalog of features and indexes in your models. Now, if we go on to the next step, so that's where we start doing model operations. We have development and evaluation of our models. That's where we do the algorithm, the evaluation. We're potentially doing, fine tuning and pre-training our models. We can use foundation models, custom models, and all of that. Now, next step is essentially the model management. So that's where, we talked a bit about foundation models, but you can manage, once you start, fine tuning, pre-training, you can do even RAGs. And that's where sort of model management comes into play into our, the whole AI system components ecosystem. And then we kind of start moving towards DevSecOps, and that's where is essentially where we have our serving infrastructure. That's how we open up our model to our customers, whether it's staff, customers, employees. So we have where we store our model assets, and essentially that's how we do the model serving. Then the next step is essentially where we do inference request and inference essentially response. So once we start serving, we have to open it up, essentially whether it's a chat or some way for customers to interact with our serving infrastructure. So that's where you have requests and then response, and obviously where model comes in. So that's where we have things like prompt injection and things like that kind of attack. So we're going to cover some of these risks in our next steps, and how to think and how to protect, and how, depending on, and because you remember if you look at the first video, we talked a bit about, where do the risks and your responsibilities lie based, from using foundational models such as, or open source models such as, ChatGPT, where, the only thing we can do is doing prompts, to all the way serving your own models, where the risk and your responsibility completely changes, because we have to be responsible for all of the AI components, as you see in this graph. Now, if we keep moving to the next slide, you can see we keep adding things like, your data for RAG. We do vector search and feature function lookup. So we need to have access from serving data to the catalog. We need to also, allow catalog access from features to actually model evaluation. So we start adding connections between all of those components, but we can potentially introduce risks, or we can potentially aggravate risks as they move between the system components. So let's look at what else we can add. And then the last bit is obviously it becomes the never-ending cycle, where from inference request and response, whenever we talk about things, for example, if you think about ChatGPT, the communication that happens between chat and ML, essentially that's where we collect more data, and that goes back into the raw data, which continuously creates that life cycle of never-ending improvement of the model. And we can just keep adding data into the raw data section, which is going to essentially goes through data prep, data sets, catalog, and then back to developing and evaluating the model, and back to serving infrastructure. So it creates an infinite loop of how we improve our essentially AI system. Now let's look a bit about now machine learning operations and a sort of a brief overview of what is the learning operations itself. So I think the important part is to understand that, I always say the similar thing, I guess, when you go into enterprise architecture or enterprise, deployments and things like that. We no longer are doing things through a graphical user interface. We're using CI/CD pipelines to build and serve our models, essentially. So we have, we essentially build continuous integration and continuous deployment pipelines that allows us to continuously adapt and improve the model. So it becomes essentially it's a way of automating our deployment and continuously updating the model. So, it goes back to the same cycle where we have, raw data, we have data prep, we have training and evaluation, and then we have deployment. But now we add those life cycles where we just covered. So, in data prep, we have data operations where we have data sets and features. Training and evaluation essentially becomes our model operations. So we have our ML models, our ML pipelines, and then deployment becomes the whole DevSecOps framework where we do ML pipelines, CI/CD, and essentially that's where we start sort of a serving infrastructure in deployment. So that's how we can sort of think and holistically view this CI/CD for ML operations. Now, if we look at, obviously I know we in security and technology love putting acronyms and scrambling all kinds of jargons, but if we look at sort of ML operations, what it is, so essentially it is data operations plus DevOps, so development and operations, plus model operations. So if we bring that whole thing together, essentially ML ops becomes where we move code and models between essentially development and production, and we manage models such as features and experiments. And then, as you can see, it becomes again a life cycle, as we kind of covered, where you can see the data sits in the bottom, where you have essentially some level of data platform, where you can have things like data governance and lineage. You have data streaming, data monitoring, and data orchestration. So, and then if you can think about all of these operations, so you have, for example, data operations where we have discovering and transforming structured data into essentially features. We can chunk and create embeddings from unstructured data. We can develop and evaluate AI via the model ops. So we training, we testing our algorithms, we fine tuning, prompt engineering models, create Gen AI agents and tools. We can chain together assets, evaluate our experiments, and then we go into essentially serving. So we have low latency model serving, we have log model requests and responses, prompt interception we're essentially doing, and then we're doing serving the data with DevOps. So again, we have query embeddings in our sort of vector databases, and then at the end, obviously the most important part as well is we need to monitor our AI. So DevOps, so we have to evaluate our model, accuracy and quality. We have monitoring, and retraining to maintain model quality, and then understanding business KPIs, the impact of the models. And then obviously underneath you have AI governance and lineage, where sort of we manage security and permissions. We track model lineage and login and auditing to make sure that we detect when things are going wrong. So this is the whole sort of ML's operations life cycle, how we should be serving data and how we should be looking at each step of where we can introduce potential risks. So once we open up and explore the whole 55 security risk framework, you will see how does that fit in all together. So let's continue moving on to the next slide. Okay, so now let's have a look at machine learning personas and a bit of an overview of what kind of personas would be working within the machine learning lifecycle as such. So we have, again, is the same lifecycle. We have, raw data, we have data preparation, training and evaluation, and deployment. But now we have personas that are covering throughout the lifecycle. So you can see data engineer that's involved with raw data and data preparation. We have AI engineer that's essentially working in training and evaluating those models. And then we have a governance officer, essentially, which just covers all the governance of the life cycle and making sure we have checks and balances in place and making sure that we have built correct policies, processes. That's where we're talking. And like I mentioned, the first part is about bringing things like AI ethics committee to play and making sure that we are uncovering the right risks, the right processes in place, and making sure that we don't essentially create incidents such as we covered in the first part of the video. So if we look at about people and process, because I think the important part is, whenever we talk about technology, it always starts with people, processes, and only then we go to technology. We need to have the right people in place. We need to build the right processes for us to be able to leverage the technology. So when we start looking at IT engineering domain and how it's split, so we have on the right hand side we have AI engineering, and then we have business operations. So on the left hand side we have someone like a business or data analyst who's an SME in the world, which is essentially doing business use case definitions, business sort of value assessments, KPIs, and sort of criteria for us to be able to leverage AI to the best of its ability. And then in AI engineering, what we kind of alluded earlier, we have things like application developer who covers and works within DevSecOps. We might even have DevSecOps dedicated engineers. In model operations, we have data scientists and AI engineers who work with feature engineering, model engineering, and all kinds of things like that. In data operations, we have data engineers, obviously, that work with data pipelines. They cover things like ETL and data engineering, data ingestion, and data aggregation. We're talking about data cleaning and making sure that we have, consistently good data. Because, I think all of us hear the phrase now, garbage in and garbage out. So in AI, the quality of the data becomes probably one of the most important parts in beginning to leverage our AI. Because if you bring a rubbish data, obviously you're going to have a rubbish output. So it's very important to have a consistently good quality data in order to build great AI models. And then obviously we have governance, so responsible for data governance and compliance, essentially, where we're doing data classification, we're doing model safety and compliance operations for that person. And if we jump into next, so as you can see through our essentially life cycle, where these specific people work. So as you can see, from 0 to 6, we have data preparation, we have exploratory data analysis, we have feature engineering, model training, model validation, deployment, and then essentially serving of the model. So you can see where the specific people come into play. So you have data engineer that obviously works with data preparation. You have data scientist that covers steps 1, 2, 3, 4, and potentially. We have data governance officer that obviously is involved throughout the whole life cycle, same as security organization. And then you have ML engineer that works steps in 4, 5, 6. And then business stakeholder, again, is working within steps 4 and 5. So you can see how you can map and cover your people and processes aligning to our AI security sort of model framework, and where we need to embed the correct resources in order to leverage this to the maximum. Now let's have a look a bit about the top risks in AI model serving, and I think this is where we're gonna come and start unearthing some of the most important parts of these AI frameworks, and how actually we can uncover some of the risks, and how we can think and plan to build mitigations, how we're gonna prevent those risks from materializing. Now, if you think about your goal is to maximize the business value from AI. So one of the most effective ways to maximize business value is to minimize risks. So whenever you think about, you have, controls and benefits. So you have potentially, 55 risks, and which goes into business use case where we have data set, models, applications, and then essentially you're going to subtract the 53 controls, essentially from the, how we're gonna prevent those risks from materializing. That's where we're gonna gain at the end the business value. So you have to think about what are the risks. Are these risks, exceeding your risk appetite? What kind of controls we need to deploy and what cost they're going to cost us in order for us to limit the risks but still extract the maximum business value. So normally, whenever we talk about security, whether it's AI security or just normal business security, we don't do security for the sake of doing security. We never are able to solve all of the risks. So the important part is to understand that we need to bring risks to the organization risk appetite, and it's always a balance and play of how we're gonna minimize the risks while extracting the most business value, while preventing from bad things of happening. So it's a play in risk management methodology that you have to leverage in your organization to be able to extract the most business value while still being able to achieve business goals and serving our customers. So let's dive in further. So this is probably the most important slide. So we covered all of those steps in, from data, raw operations, raw data, where is data ops, we have data prep, data sets catalog, model operations, DevSecOps we covered, we have, develop and evaluate model, we have model management, we have monitoring and serving infrastructure. But now, as you can see with these dots, we're going to cover and start diving in deeper into all of the risks that are potential in each step. So whenever and then what I really love about this AI, Databricks AI framework, we can hone in on specific threats or risks like, data poisoning, and then we can see in which steps are potentially possible to have data poisoning risks and how we can apply specific controls to mitigate this risk to our risk appetite. But it's very visual, so you can see how these risks are potentially evolving over your model governance and apply specific controls. So as you can see, it's very clean graphic, which covers the steps from 1 to, I think there's 12 steps in here. And then we're going to talk about specific risks. So let's look at the actual risk table for all of the steps and all of the number of risks. So as I mentioned before, there are in total 55 risks across the 12 components of AI. So if I just see, guys, you remember we talked about 12 steps. So you have raw data, you have data prep, you have data sets, evaluation, model, you have algorithms, governance, model management, model serving, you have operations, you have model serving, inference requests and inference responses, and then the platform itself. So all of this, you have 20 traditional risks, which are essentially what you have in any other platform, and then we have 35 novel risks, which are essentially specifically tailored to AI models. And then we're going to cover some of them, but just for you to sort of to have a think about, even when you're talking about, for example, raw data. So there's potentially 10 risks in raw data where you have insufficient access controls, missing data classification, poor data quality, ineffective storage and encryption, lack of data versioning, insufficient data lineage, lack of data trustworthiness, legal data risks, state data risks, lack of data access logs. So whenever you think about how you're going to ingest data, you have to think about having sufficient access control risks, making sure that data is classified and all of that things to prevent raw data risks. So once we're going to start diving deeper in actual specific risks, you're going to see how this model is very easy to use, very easy to think about and uncover those risks and build plans for mitigation. So let's look at in deeper. So first of all, obviously, I just wanted to share for you guys. So this is the Databricks AI Security Framework, where we cover sort of defense in depth through a holistic approach to AI security. So as I kind of mentioned earlier, we have, overview of 12 AI system components and 55 technical security risks. As you can see, there is a QR code if you want to get the framework itself, or you can just obviously Google and think about how we can strengthen our AI security, with specific controls and specific risks that could be used in our model development. So it's a great paperwork, and I think it's a great model to think and use in your AI operations. So have a look, guys. Hopefully you find this useful, and we can work through this framework. So in the following series, we're gonna cover and talk about top 5 AI security concerns. So we're going to talk about all of these risks, from data poisoning to prompt injection, model theft. We're going to talk about backdoor machine learning and Trojan models, lack of trustworthiness, and essentially we're going to showcase and uncover in that model operations graph of where these risks can happen. What do we need to do to prevent these risks, and how we're going to put controls to make sure that we limit our risk exposure. So let's have a look at our training data poisoning is the first risk. So essentially, whenever we get the raw data and then split it into training and test data, there are potential use cases depending on where you're getting the data from to have a training data poisoning. So it's either you are using open source data, which could be poisoned, or there are potential threat actors who might poison your data via, breach in your databases where you are lacking integrity, or any potential other risks. So we're going to walk through those risks, and I'm going to think about how we're going to prevent those risks from materializing in the first place. So as you can see, we got the same, again, system components where we covered before, where we have 12 steps from, raw data, data prep, all the way to the serving infrastructure. So now, if we think about data poisoning, I want you guys to think about, before we even start, going to the next step and reveal, where would you think data poisoning could appear in this graph as a risk, and how could it potentially be exploited? If you want to just pause the video, just have a think as a mental exercise. I think it's really important to understand, guys, through this model deployment, of where these risks can materialize, and what would we do, as I walked through previously through the risks, to prevent this from happening in the first place. So data poisoning risks, it can happen, as we kind of covered, in raw so you have, first of all, in the Databricks framework step, you have 3.1. So you have training dataset poisoning, and you have raw dataset poisoning. You also have risk 3.3, which is label flipping. So essentially you can flip the labels, because once you created, you got the data and you label that data, you can flip the label and create a data poisoning in that sense. We can also poison data in the source data, as I said, because you have source data, you have raw data, and then you have a trained data set where poisoning can happen in all of these places, as well as label flipping. And then you can have also a looped input. So looped input, as you can see, this orange line that goes around, creates a full circle, that's where we have a serving infrastructure, where we serve the model to our clients. But then obviously, once that data is potentially going back into the raw data to improve and train the model again, it could be a looped input, essentially, where integrity is being compromised, and that can create, again, data poisoning in our models. So as you can see, it's not straightforward to think about, data poisoning can only happen in raw data. There is, at least, as you can see, 1, 2, 3, 4, at least in 5 places where you can have data poisoning attacks. So in order for you to leverage defense in depth, you need to think about, how we can create controls that will prevent this data poisoning in 5 different areas of our model operations. So now let's have a look at the next step. So what are the best practices to mitigate data poisoning? So when we look about risk overview, so essentially attacker manipulates the data being used by an ML system. So malicious actor can introduce inaccuracies into our model training data, which is reflected in our output. So how we can mitigate that? So if we're talking about best practices, we can secure data by implementing network controls and access controls. We can verify the lineage of the data. We can have a data quality checks before feeding our data to the model training. We can also ensure sufficient approval stages are present to prevent the model from trained on unintended data sources. We can encrypt all of our data, both in transit and at rest, with your keys where possible, because that's very important. We can test and analyze trained models to detect signs of poisoning attack by analyzing model behavior on specific test inputs. And then we can govern and version the data both at the training and fine-tuning stages. And then we can craft, various model stages via, separation of duties and prevent data poisoning that way. So now if we look at the next view, so now we have the actual mitigation controls now applied to some of these stages where we uncovered how potentially risk could happen. So, if we look at raw data, we can apply things like automatic schema, quality and integrity checks, access policies. Then we go into data prep. Again, we can have data versioning, we can have access policies. Then if we move into training data, we can again do data versioning. Then if we go to where we have our labels and catalog, again, we can have access controls, we have lineage of data, we have classification. And then actually in our model operations, then we can detect poisoning by testing our loss function in our models. So it's another mechanism to close a loop. So essentially, if you miss any of the specific controls in earlier stages, you can detect poisoning by the testing of models. And then whenever you have a serving infrastructure, you can have IP access lists, OAuth and private links, how you're going to deploy. We're talking about training and fine-tuning, so you can train and fine-tune, deploy fine-grained models by use case, making sure you have robust data pipelines and validations in order to prevent, data essentially looped input, where we discussed one of the risks in previous steps. So as you can see, there's quite a lot going on, and that's why we talk, whenever we talk about defense in depth, we need to make sure that we maintain our controls and measures across the whole model infrastructure. So, there's a lot going on, but, we can't have data versioning in just one step. We have to have correct data versioning and data lineage across our, initial data operations cycles. We need to make sure that, we have robust access policies and we deploy things like least privilege in our model deployments, because this is the only way we're going to actually prevent from bad things from happening. So you have to think, and essentially I think that the important part is as well, which I guess we kind of didn't cover earlier, but whenever you start building model operations, you have to think about sort of doing a high level threat modeling to understand potential risks and threats that could impact your model operations or your AI deployment, and think about how you're going to build these controls into your models based on specific use cases. Because obviously you have to understand that some of these controls will be changing based on whether this model is open to the public, or it's just an internal model where you can close and have a private links and limit access, which becomes a much easier way to prevent some of the risks occurring. So and then obviously I'll show you this a quick brief, but obviously, I don't want to try, and sell you guys Databricks, because Databricks, obviously, this is just showcasing their specific internal controls, how if you're using Databricks platform for building AI operations, obviously they have their own controls and how they're going to prevent these specific risks from happening in the first place. So obviously you got, again, a list of data poisoning and Databricks mitigation controls, but they are very similar to what we discussed in earlier about, how to, have things like SSO with IDP and MFA, which essentially is access control or your identity security, and things like that. But I don't want to delve too deep, guys. If you want, just pause, have a look at it, how Databricks itself uses in the platform the mitigation of those specific risks. But basically, I'll stop here, guys. We covered quite a lot in this video, and I don't want to expand and make videos too long. So part 2 was, we covered some of the personas, we covered the actual risk framework and methodology, we covered a bit about training data poisoning attacks, and then we're going to cover the last 4 risks in the third part of our series, where we're going to dive deeper into prompt injection, model theft, lack of reproducibility and lack of trustworthiness. Hopefully, guys, you love this video. Please like, subscribe, share the video with your friends in order to make sure that we build robust and secure AI models and frameworks. And hopefully I'll see you guys in a video number 3. Thank you.